Welcome everybody, and especially welcome to Ed coming over here from the States just for this workshop, which I think is really amazing. And I'm really very happy that you all were willing to come here and to work with us today for this workshop. It's a closed workshop, as you know. We invited you to come here. We will maybe organize another one at ACL next year, and that will be more open internationally. But here we want to test our main ideas. We want to have your input, your critique, your inspiration. So it's kind of a long brainstorm session the whole day. So I will just give an introduction, and then I will hand over to Martin and Filip, the two PhDs that actually did almost all the work, I think, and organized this together with Selena in the back. And they will guide you through the day. So just a few things. For me, I think, okay, big data, big buzzword, nice, but I think what really matters is the small data. Maybe you can use big data for that, but you need to be able to understand or deal with the small data, especially if it comes to language. And we are here as a kind of not everybody, but most of us work in the area of language and computers. And language is a kind of a strange thing, because the language system is that big data. We don't actually know how big is the system of a language. And a lexicon or vocabulary can be pretty big, but the one that people use is not so big actually. But language use, we know, that's big data. So here, I really like this picture that I found on the internet. This picture shows you 5 generations of Armenian women. So it's the baby, the mother, the grandmother, and the great-grandmother all together. They all 5 are alive, as you can see. So they share a language system, Armenian language. And they use it among them. They communicate through five generations. And partially they live in the same world about which they talk. So they may use language differently among the generations. Of course, this is one of the oldest scripts. It's actually also used in this area. The language language changes slowly, but not so slowly, and they're not using this anymore. It evolved, they changed. But the thing is, the world changes way more rapidly. We know this since today, with Brexit, everything changed from yesterday to today, or somewhere halfway in the middle of the night, the whole world changes, and we don't even know how much it changed. In the meanwhile, language changes slowly, as said. So we now have the Nexit coming up, the Dutch potential exit from the European Union. People create new words for this. The concept is there. But it's not as quickly as the world changes. But if the language doesn't change so rapidly, and it cannot change rapidly because you have to be able to pass it over from one generation to the next one, as 5 generations of Armenian women, that means, by definition, that the relation between the language and the world changes constantly. When the world changes and the language only changes slowly. That means that our models need to be able to capture this dynamicity of the relation between the world and the language. That's one of the core things that we want to address. So an example, this is a small data example. It's just a kind of a small story. A friend visiting you, and you play a game of chess. Everything fits together here. You can even see the picture before you. And while you are doing this, playing chess with the white queen being captured too early in the game, so that all relates to the game, you start talking about another topic. And we have no problem understanding this either. The picture is still there, the other topic is there, it fits in, blends in into this coherent story, and you start talking about Anna, 13 years old, and she's starting with high school in September, and then you go to the pub just around the corner and you drink a beer. This is all small talk. It's small world, small data. It's you and your friend in the context of a chess game, your personal environment, the daughter that you have, and the pub that is around the corner. That is the way we read it and interpret it and build a picture. 2 years ago, when we started with Spinoza, we turned this into a puzzle like this one. This is the puzzle to be solved. So just taking WordNet census for every word in there, imagine has 2 meanings, visit 11, friend 5, and looking for entities like there are 42 Annas in Wikipedia, and I think there are something like 5 O'Neills that you can find in Wikipedia. There are many more Annas in the world and many more O'Neills in the world, which Wikipedia doesn't even give you. And if you turn it into a puzzle, it's an impossible puzzle to solve in that sense. From a technical point of view, the number of combinations is absurd. What does our systems do, or the systems that we design? Well, they would read a story like, interpret it like this. The White Queen is a TV series, and Anna is the Japanese Airlines, being 13 years old, and O'Neill is an equipment sports store where you apparently can get beer. This story that the computer generates doesn't make any sense. It doesn't create this small, let's say, world that you can visualize. There is no coherence here. It's based on popularity. And we think that this is caused by the fact that the way we design tasks and evaluate systems and develop systems or challenge people to build systems, they can set the state of the art by using popularity rather than looking at small data and coherence. And this is a well-known thing that if you look at all the data, that there is a lot of data for popular concepts, and that but there is a huge long tail of small data. Together may make up as much data as the popular data, but the problem is for each of those we only have little data. So the problem, I think, is that even though these machines, whatever learning you do with the machines and how much data they will give you, you can see that they make extremely stupid mistakes that a 6-year-old will never make. And a 6-year-old hasn't read so much text as these machines did, and or got as much data as the machine has. The 6-year-old doesn't have a whole Wikipedia, Wikipedia in memory, doesn't know about all these cities and places and companies or presidents, or so in terms of access to knowledge. The child has way less knowledge than the machine has, but it has a kind of intelligence that the machine doesn't have. And that's the kind of intelligence that you need to read the small data and be able to create this coherent story. Okay, so the challenge of today, and then I give over to Martin and Philip, is we want to create a task or a challenge somewhere in, let's say, Semival 2018. And for this, we need to create data set which will force systems to use more intelligence. So there's no way you can succeed or to perform well on these tasks if you just restrict yourself to the most popular interpretation. I'm not telling people that you're not allowed to do this, but it will be very difficult because we want to create the data exactly in that way. We want to increase artificially the complexity and the ambiguity. So if you would take a random sample out of the world, you won't have that complexity and ambiguity. You will have a set of small data. But in the small data world, there is only one concept relevant. You just have to figure out which one. In our task, we'll have artificial ambiguity. So we will connect one form with multiple interpretations and you don't know which one. It will force the machine to understand this small data, as I explained, with all the little details in this, because you need the details to figure out what is a coherent picture. And in advance, you don't know what small data world you will get as a task. So you don't know it in advance. So it's not a domain task. You don't know the domain. It's a collection of different things. You have to figure it out as part of the task. That's the idea. Okay, so that's my introduction. I now move over to Philip, I think, who will go into a little bit more details, how did we got to this idea and where do we want to move towards. So, Philip?
Okay, hello everyone. My name is Filip Ilievski. I'm one of the Spinoza funded PhDs at Piek Vossen. So with Martin together and with Piek and Selene Coleman, we organized this workshop. and I would like to expand a bit on what Piek said in his introductory speech. So this is this is essentially a continuation of expansion a bit of what Piek mentioned earlier. Also, I will talk a bit about which work did we do related to this, and introduce the main practicalities of the day-to-day. Well, this workshop is mainly about looking at the long tail, as Piek mentioned. So this the long tail as itself is not the new concept that we introduce here. So it's fairly common in different areas. That's why we have people from different AI fields being here today. It's also very apparently exciting phenomena for all these concepts, and it ties up to very core problems of AI up to today, like the whole contextual reasoning, contextual interpretation of situations. So it would be, we hope, a very exciting day today, and we probably can learn something from all this and build this very awesome task later. But before I go into the content, just a few practicalities about today. So this is essentially how we have envisioned this day. So we have currently the introduction session is ongoing, after which we have 5 invited talks. After that, we have a lunch of 1 hour, which will be served here to us. We have the keynote by Edward Hovey after this lunch, and then we go to the practical session, in which we try out different methods in 4 tracks to see how we can build this disambiguation task, or brainstorm at least about this. After that, we have a central presentations, and we wrap up this day, after which we go for drinks at a place nearby, so we'll guide you. In terms of food and beverages, so just to mention this, so there are 2 official coffee breaks, one in the morning and one in the afternoon, and there are coffee machines in the hall, but apparently they're also serving coffee here, so it seems to work out fine. The lunch will be brought to us at 12:25, so and in terms of drinks, as I mentioned, we go after the workshop. The final thing is we have set up, well, we are using already before the workshop this Twitter hashtag, Spinoza Longtail. So for whichever questions, remarks, complaints, thoughts you have, or if you have your slides and online and you want to link them to SlideShare, or share a nice link related to your work, this is mainly for the speakers, but also for attendees. If you have anything you can think of, you feel free to link it to this, so we can also discuss online throughout the workshop. Okay, so that's around the practical. That's around the practical stuff. Let's go to talking a bit more about the content now. So the long tail. To talk about the long tail in language, probably we should go one step back and talk about the world. So as Piek mentioned earlier, we have the language is essentially, we use language to refer to things that exist in the world in which we live in. So every generation uses language to refer to concepts and instances that are relevant for the world of that time. So talking now, sorry. So that is something that is our starting point here. So we have all these fluid worlds. So the world in the 50s is different than the world is today, and also people's knowledge about that world has changed. To illustrate this through a very nice example, if we have these 5 dinosaurs that have been born in different ages, let's say the earliest one has been born somewhere in the 50s, and or actually has been living somewhere 50, 60 years ago, and the current one is a dinosaur that is living today. Well, one fun thing about dinosaurs is that, as our example figures here, they also die out. So if you talk about the earliest dinosaur here in the 50s, if you talk to him about Ronaldo, probably he has no clue what you're referring to. So he doesn't know if it's a concept, if it's a person, if it's I don't know, a god or food or whatever. He just doesn't have a clue. If you talk about Ronaldo with the next dinosaur maybe in the 70s, then he knows stuff about then he knows this only one person, which is some defender player of Brazil, which essentially is not in the memory of the people already 20, 30 years later. So this is a person which people don't know much about, for instance, today or some time ago. But we do know about these other Ronaldos that have appeared at the later stage. Um, okay. So in order to study all these worlds all these changing, in order to study these changes in the world over time, what we essentially we cannot take all the communication that exists at the specific point of time. So we are unable to just get all the language use of the 50s directly. So in order to study this, we take proxies, and these proxies are our NLP datasets, our disambiguation datasets in the language processing field. Um, so as these datasets have been created, well, they have a timestamp, so they have been created at a specific point of time. We can assume that they are relevant for the point of time in which they have been created. So if you have a dataset which is from the 19th century, you can think that it actually captures some things that were very relevant for that time. However, one thing that these datasets also do is that they represent a subset of the world, which is kind of expected. So you cannot expect the dataset, of course, to cover everything. So they represent a subset of the world, but also they overrepresent some of the things in this subset, and this essentially results in these datasets covering very well what we call the head of the long tail curve, and covering very little or just accidental details from the rest of the world. So examples like Anna or some O'Neill local bar will appear only accidentally in some datasets, but they're well, it's a long tail because there are just too many of these, and they appear only accidentally in some datasets, while the head of what is known in the world is very well represented. This so expanding on this further, so just looking deeper into this depicts two phenomena of language. So this long tail phenomenon of disambiguation has essentially two subparts when this styled. One is that people don't use all the possible expressions to refer to all meanings in the world. So as Piek mentioned, we do make a selection to refer to a specific situation with a specific term, and this is something that is a trade-off between several factors. So one is we want to use a subset because we cannot just name everything in the world with a different name. We also cannot name everything in the world with the same name, because then we'll have just too much ambiguity to resolve. And finally, the context also matters. So whether the obvious has been stated in a specific situation also determines how you refer to something. So if you want to refer, the example was if you want to refer to your local Jon Snow person from your local street or whatever. I think this was from a newspaper a few days ago. Then you have to say Jon Snow, but not the one you think of. So you have to really specify in these cases your context that you refer to. The other side of this coin is the distribution of this. So we do have, let's say we already said that we use a subset of these expressions and meanings, but these are not equally distributed. So everything in the world physically does appear once. So we are all, so me and Ronaldo and I don't know, Obama, we all exist once. However, in the usage of language, this is illustrated differently. So some things are talked about a lot, some things are very prominent, and many others are just used in very local contexts. So essentially, there is a Zipfian distribution when it comes to the usage of language. Okay, this blurry picture shows these three different curves that we are talking about. So the brown one is the physical layer, which essentially where we want to show that that everything in the world. So these football players, they're blinds, the father and the son. They're both as physically as important as any other. So they exist once. And when it comes to the language use, in 2007, the father was much more important for general person in the street. So he was much more talked about. He was much closer to the head, so to the peak of the head, and the son was not that relevant at that time. Consequently, also there was a similar situation when it comes to the language phrases that people used, the language expressions. So blind was also a very popular phrase. Consequently, to the fact that the actual meaning corresponding was very prominent. And there are a few other factors, a few other things illustrated on this image. So one is that in order to, if you say blind in 2007, the default meaning is the father. But also there is variation here. So to refer to him, you can also say Danny blind, or probably more cases. So we tend to give more names to things that are more popular, to have more variation there. On the other hand, to refer to the least popular and to less popular entities, to less popular concepts in the world or instances, we have to be more specific. So this is the similar idea as earlier. And finally, what this picture illustrates is also the temporal change of language. So only 9 years later, we have the same two people, but only now, if you say blind, now people think about the sun. So I'm not Dutch and I don't like football too much, but I trust Martin. This is a correct example. So, okay. So on our side, I mean, okay, so these are some theoretical background information, and this is something that that has been studied quite well. However, we have been working on some practical investigation of how is this in the datasets that are currently used for disambiguation. And we used we did that over 5 different disambiguation tasks. So event coreference, entity linking, nominal coreference, word sense disambiguation, and predicate disambiguation. So we thought, well, there are quite some things common between these 5 tasks. So why not just see whether we observe similar phenomena across tasks? So this is a bit generalized. So eventually, in some of these data sets, it has happened that people have deliberately increased ambiguity or variance. So that is, for instance, in the ECB plus corpus. However, in most of our data sets, the ambiguity and variance are both close to 1. Which means that essentially that's the bare minimum. Which means that every data set has essentially no ambiguity. So if you just say Ronaldo, it will always be the most popular Ronaldo which is there, or at least the same Ronaldo, and that one very often coincides with the most popular case. We have more analysis, so I'll go further. And we also looked into the temporal, the time of creation of these data sets. So there has been the distribution. We thought this was also interesting. So there are several peaks at which these data sets have been mainly created, or sorry, at which the documents typically come from. So many datasets come are based on the Brown corpus from the 60s, and well, they're essentially yeah. So many of these Connell or Sensival tasks they contain data from the Brown corpus. So there are those piles. And then when it comes to entity linking or event coreference, most of the datasets have been created very recently, so in the last 10 years or so. Another thing that we observe, so this is specifically for the entity linking task, so we looked into the relation of the page rank, which we find in our datasets. So essentially all of these are our datasets except the first one. So you can see that they are all orders of magnitude more dominant than what we have on average in our background knowledge sources. So this is another proof that we have mainly that we are mainly representing the head in our data sets. Okay, so why is this relevant? So as Piek already mentioned, this is relevant mainly because this causes also us to create systems that expose the same bias here. So by training and testing on very popular data, we can build systems that can perform very well on popular data. However, it's just unfair to expect from the machines to perform well on the long tail. So okay. And this is also there is also the whole contextual dependency here. So what is this is further what complicates this further and why this makes it a bit more fluid and fuzzy. So if you say what is popular in a general domain, maybe so the popularity may switch across different domains in terms of topic, but also time or location or community. And in terms of systems, we have performed some analysis as well. So this is done by Martin. The analysis here is that the attempt here is essentially to go from a system that performs very well on the head and quite bad on the tail. So this is in terms of word sense disambiguation, to improve essentially the performance in the tail. The outcome of this experiment was that by improving the long tail performance, Martin got a bit worse, quite worse performance on the head. So it's interesting that there is also this kind of balance, that if you increase one side, you get problems on the other. So this is also why we would like to go further here and have somehow incentivize for us to build systems that can perform good on the long tail as well. Okay, so the goals of this workshop are essentially to, as Piek mentioned, so the most practical goals are to go for SemiVal 2018 task, which will be on long tail disambiguation, and to have another workshop, but now open and more global at ACL in 2017. And we have a lot of wishes here. So we want to build systems that should discriminate from one context to another, use more semantics, logic, inferencing, and so on. And we don't want yet another domain task. How do we want to do this? So going from wish is a bit more practical. So we look into these 4 components of a disambiguation task. That is, so essentially the system or the algorithm that the system uses, then the datasets on which it trains and tests, the knowledge resources it uses. So it's very common in disambiguation tasks to use various sources of knowledge, and the evaluation methods that one could use. Now, in our department, we mainly worked so far in the datasets domain, in the datasets track. Oh, by the way, these are the 4 tracks also of the whole afternoon session. So in terms of datasets, we have the main things that we are interested in are how to build this. So what are the best datasets in order to challenge these systems to perform well on the long tail disambiguation task, in terms of what should be the properties of these datasets. So here we look into stuff like ambiguity or variance or dominance, temporal diversity. So we try to quantify these concepts in some kind of metrics in our work. Should these datasets be multitask, and how many tasks can we actually put there? How many tasks should we combine in these datasets? How much is it sensible to go for? Are the current datasets sufficient? So how much of the whole space do we actually cover with what we have currently, and in which direction should we expand? So this is related to the properties question. And finally, if we do need other datasets, then how do we go to collect this knowledge? And we have created 3 corpora in the past to work on, which tackle separate cases of this. So one is the meantime corpus, which is a multitask corpus created now, published a few months ago. the Dutch SEMcore, which is a balanced sense WSD, the word sense disambiguation corpus, and the ECB plus, which was deliberately created to increase the ambiguity of the previous ECB corpus for event coreference. In terms of knowledge resources, the main question is what kind of knowledge do we need for this long-tail disambiguation task? So how to create, but also deal with and reason over this long-tail knowledge bases, also the contextual ones, and so yeah, so how to create this and how to locate this knowledge actually automatically when dealing with this. In terms of evaluation methods, the main question is how can we evaluate these systems in order to essentially incentivize for them to perform well on the long tail. So what is the optimal evaluation metric or metrics? Can it be generalized over various tasks? And well, yeah, how can we incentivize the systems that we want? And in terms of systems, so they are on the other side of all these. The main questions are how do the existing systems perform? So maybe gaining more insight into this would also help here. But also how to ensure good performance in the long tail, and how to build sustainable systems that will not be thrown away after 5 years when new data comes in. And that's it. Thank you.